welcome to experiment number 2, digital output. For the experiment, our objectives are to learn how to create a project and build a project, to understand how to final code program to the microcontroller, and to create a simple code for controlling an LED. So we will be using the MPLAB IDE to program our microcontroller. So now we are going to create our new project. So microchip embedded, standalone project. Next. We are going to use a PIC16F18875 microcontroller. So there. Next. Then we are going to use an XC8 compiler. Let's name it GGXP. There. Finish. So once it's loaded, let's go to Tools, Embedded, and select MPLAB Code Configurator V4. There. So once the configurator is complete, let's save our myconfig file, MCC configuration file, save. We have 3 peripherals: interrupt module, pin module, and system module. So first, let's go to pin module. So in the pin manager, we will select the RA4 output for the LED, RA4, then RB4 for our switch. As you can see in the pin module, the analog and output tick box on RB4 should be unticked. Then tick the WPU for the RA4 and tick the analog output should be ticked. Let's name the RA4 LED and the RB4 switch. So for the system module, oscillator select HPin TOSC, high frequency internal clock 4 MHz, clock divider 4, then low voltage programming enabled. Then let's click generate. After the generation is complete, let's go to projects. Let's go to source file and the main C file. So for the first test, we will create a code wherein our LED will turn on when our switch is turned on, and our LED will turn off when our switch is turned off. So let's create the code. Else. Okay, then after that, build. So after the build is successful, we will use MPLAB IPE. Using the MPLAB IPE, we will connect our PIC3 to our PC. Here, the PIC3. Then we will connect it to the PC or laptop using a USB cable. So MPLAB IPE should read the PIC3. So here is the pin 1 indicator. For the first pin, this is the MCLR or VPP. Second pin, VDD target. Third pin, VSS ground. 4, PGD or ICSP data. For the fifth slot, ICSP clock or PGC. So now these pins will be connected to the specific pin configuration for this specific IC. So I will also show you the pin configuration for PIC16F18875. So the MCLR pin will be connected to the first slot. The VDD target will be connected to the 11th slot. VSS or ground to the 12th slot. Then the ICSP data, 40th slot. And the ICSP clock in the 39th slot. Let's go back to MPLAB IPE. Then settings, advanced module. Password, microchip, power. Power target circuit from PIC3, check. Voltage level, set it to 3125. Then operate. Then let's connect our PIC3. Browse the hex file that we created in the MPLAB IXDE. The corresponding folder, CG, AXP, list, default, production, then here's the hex file. Now that the hex file is loaded successfully, we are going to program it. Now that programming is complete, it's now time to test our program microchip. Let's connect our positive terminal, negative terminal, then the RA4 which is in the 6th slot here. Let's connect a connecting wire there. Then LED. Let's connect a resistor, the other end of the resistor in the ground. So for this microchip, all VDD and all VSS pins must be connected at the circuit board level. Allowing one or more VSS or VDD pins to float may result in degraded electrical performance or non-functionality. The VDD first, so 11th slot there. Let's connect it to the positive terminal and the other VDD on the 32nd slot. Now let's connect the VSS to the ground, which is the 12th slot, and 31st slot, the VSS. So here I have a switch with a positive terminal and negative terminal. For the RB4 pin, it is located in the 37th slot. So, and let's connect the negative terminal of the switch to the ground circuit. Now let's turn on the switch. off. As you can see, once I turn off the switch, the LED turns off, and once I turn it on, the LED turns on. For the second test, we are going to modify our code wherein the LED will blink at 2 seconds interval once the button in RB4 is pressed. Let's modify our program. 2000 for 2 seconds. Then let's change this to 1000. Then let's build it. So once the build is successful, would you like to reload the hex file? Yes. Then let's go back to our MPLAB IP. Then let's connect again our microchip, MCRL first slot, VDD 11 slot, VSS 12 slot, IPSC data on the 40th slot, and the clock on the 39th slot. Browse again the hex file. Hex file loaded successfully. Then let's program it. So there, programming complete. Let's disconnect the VSS and VDD. Now let's test the circuit. Once I turn it on, the LED will blink at 2 seconds interval. So once I turn it off, it turns off. But once I turn it on, the LED will blink at 2 seconds interval. 1001, 1000, 1001, 1000, 1001, 1001, 1000. For our third test, we are going to create a program wherein the LEDs in RA1, RA2, RA3, and RA4 after the button is pressed in 1 second in RB4 will light up. Let's go to the pin manager, click RA1, RA2, RA3, and RA4. So after the pin manager, let's go to pin module, untick the analog, uncheck the analog. Let's rename this as LED1, LED3, LED4, click generate. So once generation is complete, let's go to main C. So based on our test, all 4 LEDs will light up after 1 second when the switch is turned on. Let's change the value to 1000, then LED 1. So now, after that, let's build it. So build is successful. So the loaded hex file has been modified externally. Would you like to reload the hex file? Yes. So let's just return our connection of PK3, the VDD, and VSS. Now let's go to MPLAB IPE for their hex file. Hex file loaded successfully. Then program. So once the programming is complete, let's now again test our circuit. Let's connect the VDD and VSS from PK3. Now let's connecting wires in RA1, RA2, RA3, and RA4. So for RA1, 3rd slot, RA2, 4th slot, RA3, 5th slot, and RA4, 6th slot. Then let's connect LEDs. Then let's connect the resistor and the other end of the resistor to the ground. Now let's test the circuit. So when the device is turned on, after 1 second, the LED should turn on. So let's count how many seconds the LED will light up after I turn on the switch. 1001. If I turn it off, the LED turns off. So let's modify the program wherein the LED 1 will light up after 1 second, LED 2 will light up after 2 seconds, LED 3 will light up after 3 seconds, LED 4 will light up after 4 seconds. Now let's modify the program. Set this to 2000. 3000, 4000. Now let's build the... Once the build is successful, let's go back to MPLAB IPE. So let's connect the VDD and VSS of our PK3. Load our hex file and click program. So programming is complete. Now let's test again our circuit. I turn on the switch. There. So let's modify our code wherein LED1 will blink at a rate of 250 milliseconds. LED2 will blink at a rate of 500 milliseconds. LED3 will blink at a rate of 750 milliseconds, and LED4 at a rate of 1 second. Now let's build the program. So the build was successful. Like to load the hex file, yes. Let's go back to IPE. Browse. Again. Now let's connect again our PK3, VDD, the 11 slot, VSS 12 slot. Then click program. So once the programming is complete, let's disconnect our PK3. Then let's test our circuit. So let's turn on our switch. So with the modification of our code, we were able to execute the program.